Welcome to a new deep dive. I'm your host, and today, well, our mission is fundamentally questioning 95% of the entire universe.
Yeah, I'm your resident expert for today, and this is a big one. We're unpacking Boris Krieger's book, The End of Dark Cosmology.
Right, so he argues that the dark matter and dark energy we've been, frantically hunting for decades, they aren't actually missing invisible particles.
Exactly. He's saying it's just the natural physical weight of empty space itself, which sounds simple, but the implications are wild.
Just to give you listening a sense of scale, imagine you measure a room, but your math isn't just off by an inch, it's off by 120 orders of magnitude.
A 1 with 120 zeros after it.
Yeah, you're off by a scale literally larger than the visible universe.
It's an error so massive that human brains just cannot picture it, and yet, that is the exact scale of the error that standard cosmology might be working with right now.
Which is crazy, and I saw in Krieger's work that he traces this huge mistake back to a specific mathematical shortcut from 1967.
Right, so Yakov Zhilovich, he was a physicist who basically looked at the math for Einstein's cosmological constant.
Which is the energy of space stretching, right?
Exactly. And he compared that to quantum vacuum energy, which is the buzzing, popping energy of subatomic particles.
So they looked similar on paper, and he just combined them.
He did. And that one assumption absolutely derailed things.
Wait, really? Just combining those two concepts broke cosmology?
Pretty much. I mean, when you use quantum field theory to estimate the energy of that buzzing subatomic vacuum and then assume it's the exact same physical thing as the cosmological constant, you get that 120 orders of magnitude mismatch.
The worst prediction in the history of physics.
Widely considered the worst, yeah. Krieger argues we have to divorce these two concepts. They might wear the same mathematical clothing, but they're entirely different physical mechanisms.
Okay, so if we separate them, Krieger brings in the Swiss cheese analogy. Like, if the solid cheese is galaxies and stars, the holes are empty space.
Right, but his argument is that those holes aren't actually empty. They're filled with a heavy gravitating quantum vacuum.
But if I'm being skeptical here, isn't swapping out dark matter particles for heavy empty space just, trading one invisible ghost for another?
Well, no, because that is the crucial distinction. They aren't both ghosts. Dark matter particles are purely hypothetical at this point.
Right. We've spent billions on underground detectors and found literally zero particles.
Exactly, zero. But quantum vacuum energy, on the other hand, is already a proven experimental fact. Take the Casimir effect, for instance.
Oh, the one with the metal plates.
Yep. If you put two tiny metal plates extremely close together in a complete vacuum, they actually get pushed together.
Because the empty space around them is actively boiling with temporary particles that physically push on them, right?
Exactly. The vacuum has energy, and as relativity tells us, energy equals mass. So empty space literally has weight.
So we aren't inventing some magical new particle. We're just finally accounting for the actual weight of the space between the particles.
Which brings us to the early universe.
Right, because if empty space is physically heavy, that extra mass must have acted like a gravitational supercharger back then.
Precisely. And that perfectly explains the massive headache astronomers are having right now with the James Webb Space Telescope.
Oh, the early galaxies. JWST is looking back at the dawn of time and finding these giant, mature galaxies that just shouldn't exist yet, according to standard models.
But Krieger's math predicts exactly this. He calculates a coupling constant, which is a number that dictates how this heavy vacuum interacts with matter.
And he sets that at 0.005, right?
Yes, and the amazing part is he didn't just pull that number out of thin air.
Right, he derived it directly from the internal energy dynamics of a single proton.
Which is wild, because he shows that the microscopic physics holding a proton together scales all the way up to the gravitational pull of the entire cosmos.
So it connects the absolute smallest building blocks directly to the largest structures.
Exactly.
Which creates a literal pressure cooker in the early cosmos. Think of it like beer foam.
I like that analogy.
Yeah, instead of just a loose soup of gas, that dense, heavy vacuum clamped down like tight foam. That intense pressure forced hydrogen to compress and ignite into stars at a hyper-accelerated rate.
Spitting out those giant GWST galaxies way ahead of schedule.
But wait, if the vacuum was a high-pressure cooker back then, why am I sitting here drinking coffee instead of being violently crushed by heavy vacuum gravity?
Well, Krieger explains this through a mechanism called nonlinear self-screening.
Okay, self-screening. How does that work?
Think of the expanding universe, like stretching out a massive elastic fishing net. The knots in the net are the galaxies, and the spaces between the knots are the cosmic voids.
So as the universe expands, you pull the net outward.
Exactly. As you stretch the net, the empty spaces, the voids, thin out and expand. But the knots, the galaxies, pull tight.
Ah, so the dense vacuum energy gets localized and trapped inside those tight knots of matter.
You got it. Space acts almost like sour cream spreading on an expanding rubber membrane. The overall expansion flows around the galaxies, while the heavy vacuum stays locked inside them.
And that trapped vacuum provides the exact extra gravitational grip that keeps stars from flying away, the exact grip we've been mislabeling as dark matter.
It completely strips away decades of unnecessary complexity. Nature is just using the heavy vacuum that was already in the room.
So what does this all mean for you listening? I mean, you don't need to be an astrophysicist to appreciate the elegance here.
Definitely hot.
The universe might not be filled with magical, undetected dark particles playing hide and seek. It might just be built on the straightforward physics of empty space doing exactly what the fundamental equations always said it would do.
It's a huge relief, honestly.
But if you take Krieger's math to its absolute extreme, it points toward a block universe. A reality where the past, present, and future all exist simultaneously as a single, unchanging structure.
Right, where the universe doesn't mathematically expand through time, it just exists all at once.
So I'll leave you with this to ponder. If the cosmos doesn't actually move through time, is your everyday experience of time passing just a neurological illusion? Maybe we didn't measure the room wrong. Maybe the room is just eternal.